Thanks. Hope you can hear me well. Yes, this is going to be my topic. I am Martin, also from Infinum. And yeah, let's just start. So the topic is a closer look into SwiftUI body invalidation. And this topic doesn't have a lot of necessarily those production value, but it's fun to take a look at, I think, if you start to think about it. So I would divide this topic personally into two distinct phases. First phase would be the attribute graph and then the view diffing. The view diffing part, that's the less interesting part in my opinion. It's once you get those change somewhere in the view above, how that change trickles then down to the view hierarchy and then changes the things to reload. And the more interesting part is this attribute graph part, and that's the really cool stuff where you go into SwiftUI, C++ underneath, how this triggers certain property wrappers and stuff. And if you're excited about this as I am, you can take a look more about that here. But unfortunately, we're going to be looking at the other thing. But it's still going to be pretty fun. So I don't really like doing slides, so I took a bit of a risky approach and decided to code this live, to test this live. Hopefully, I'm not sure how I'll do this with the microphone, but we'll see if you can hear me. Escape. Cool. Switch. Nice. No? Okay. So yeah, I prepared this zoom because we'll be needing this, and this is you cannot zoom this. So let me put this down and do the plus plus. Is this visible? Yes. Cool. What? Ah, okay. The microphone. Cool. So. We are, yeah, cool. Thanks to my lovely assistant. Okay. So in the beginning, there was data, and it was plain old data. E-O-D, here. Yeah, allow me some snippets. And this is plain old data. Oh, zoom. What is plain old data? That is like the most basic data there is. That is, if we take a look at the definition, which I will show you right now, it is pod, no, P-O-D, is pod. Okay. If you take a look at the definition of is pod, this, come on, Xcode, no. If anything doesn't work, it's Xcode. We can do it like this as well. I don't mind that as well. Anyway, well, we will have to trust me in this one, but double check later. Plain old data, or this function, basically says that anything is anything that doesn't have some copy mechanisms or destruction mechanism, that is plain old data. And basically anything you build from this data is also plain old data. In this case, integers are plain old data, doubles are plain old data, and UIDs are plain old data as well, because internally they are just like some very simple storage that doesn't do anything. And when we, well actually, it would be nice for me to explain what we're actually doing here. So in this case, you see we have this recompute property. This is state object because it was easier to implement. And this gets called every second. So this causes this to get called. And what we are curious about is when this will get called. And you see here that I have these print changes, and then this is the regular at self changed, at identity changed, or things like this that we are going to be tracking. And if I run this app now, excuse the build times. If I run this now, you can see that this is indeed plain old data, and that this, well, it's it's supposed to be okay. Okay. So now currently we in this body of ours we have nothing, so there is nothing for view to f against, and we can understand that this body is going to get called only once. But as soon as we add something here, plain old data, and run this again, and if we track it here, this is less zoom than I hoped for. If we track it here, we'll see that it changes all the time. Why? Because this, well, I don't know how much you know, but this UID is randomly generated, so each time it generates, this thing gets called here, and which then this SwiftUI checks again this, it sees it's different, and then it will, you know, knows that it has to update everything else to see, so that the actual view display has the correct data to show. And if we remove this UID, it will not be called as many times, but I will spare us the pleasure of that. And of course, we might want to try to mitigate this, but making this equatable. Actually, I have a snippet for that as well. No. Oops. Okay, pod equatable. And we see I made it true, but I can make it, I made it always true. So in theory, if SwiftUI is checking equatable, this should always work, but you will see that it does not, because SwiftUI can basically, if this is plain old data, it knows to do this better than you or faster than you, and then it will always check the memory underneath. So yeah, that's the most basic case, and I thought it would be a good idea to start there. Yeah, but alas, people have had enough, and they want to something more exciting. So what is better here to do than introduce exciting new data? Exciting new data, yes. And this is new and exciting as it can be. And this, as we shown in our previous, well, as we didn't show here, it has some copy on write things and has some deallocation and allocation. So this simply cannot be plain old data. So how does SwiftUI decide to check against is well, there are two types. There's value types and the reference type. In this case, it's a value type since it's a struct. And SwiftUI, what SwiftUI does is it will check, well, reflectively if, hey, can I check you, can I check you, and then can I check you. And in this case, if we have exciting new data, that's always the same. How I'm going to take a risk and say, does anybody want to say what's going to happen if I run this exciting new data now? Does anyone want to guess how the diffing is going to be done, or is this going to be called once or many times? Multiples. Yeah, true. That's a good guess because it's correct. It's not a guess. Well, it's doing that because, in case anybody was wondering why, because this reference gets created each time. So how SwiftUI is doing this diffing, it's checking, hey, this string is obviously the same, this array is the same, but this view, while it's the same, it has a different internal reference, and when it comes to classes, SwiftUI only checks for the class reference. So it has, this is the same string, same array, but again, this view is the same. But in this case, since this isn't plain old data, SwiftUI doesn't trust itself more than it trusts us. And if we actually make this equatable, and you can see this flipping in the background, that means it's reloading each time, it's a random color. And if we do this and the equatable, and we run this now, this equatable, I'll put it true. I don't know why I put false here, I don't need it to be false. And now it's actually SwiftUI will listen to us after a couple of tries. And now it knows not to actually make those changes. You can see the color stays the same. And this, it will listen to us when we put equatable. This doesn't work always. This works in this example, in this version of Xcode with this version of SwiftUI. And even here, it doesn't work always. I will show you when it doesn't work. And if you actually need this need this, you will use equatable views. And that's why, yeah, not really a lot of production value, but still cool to know. So let's also just finally check classes and AOC, any old class, I don't know, this one. And also, yes, if we have this shared version, this is always the same reference, so SwiftUI will know how to not check against that. I will not be showing this. I thought I might, but I think you all get the gist. And if I put this, and yes, and classes check for equality. If I put a shared class and put here false, and the old class, it will reload many times once this builds. Please, okay, cool. Was afraid for a moment there. Okay, cool. So this is it about classes and structs. What other data types we have? Well, we have existentials, meaning protocols. Protocols, they can have anything inside it, and I'm not going to go into them. I'm just going to say it works pretty much the same way. SwiftUI will know if you boxed something, and it will behave as a struct or as a class or as a plain old data inside there, but it will have to check a few times. Like if you put a protocol, your body might be called a couple of more times, but it will not be called like an infinite amount of times or something like this, something crazy like that. Yes, I'll take questions now if somebody wants to. Well, actually, that's a bad idea. No, I'll do it. Is any questions regarding this? Maybe. Okay, cool. Then we can move on to the next part, which is, I hope to be more exciting, and this is the cool stuff. Move to example 2. I made this a bit unnecessarily complicated. Example 2, okay, this is still going forever. Spoilers. Okay, so what else can we put in there? Well, of course, we can put closures. And now we put this very basic construct. We have this closure here, and we have this recompute here. This capture this basically. So again, any guesses on when we run this? How many times it's going to get called? Don't look at this. Once, many times, 3 times. Well, I'll show you then. Well, because I already kind of did. If we rerun this, we'll see that it runs many times. And to answer this question, why, which I'm sure you're all wondering why, or if you know, then you're not, but let's say you don't. What we need to first answer the question, what is a closure itself? So a closure itself it's not magic. It has to have some internal representation. And if we put a breakpoint here, we can take a sneak peek into that representation. And I'll zoom this. Oh, great zoom. I can zoom it more. I discovered this like yesterday. Pretty cool. Cool. Closure. So closure, it has this basically. It has a memory address. It has a convention-tin function. Not really necessary. We can pretend that this belongs to this. So this reference is this function reference. And we have some context. What is the context? Context is a capture list. So basically, SwiftUI is doing this, diffing this when it's diffing the function. And we can, for the most part, pretend it's doing the same job as when we were using these data types ourselves. So if this context is classes, it will check references. If this context and if the reference doesn't change, it will not retrieve anything. If this function pointer stays the same, it's not, but let's pretend this is this function pointer. If it stays the same, then it will not need to recompute everything. But now if you look at this, and we jump this many times, and I keep this here, we can see that this context changes. So that's why it's getting recomputed. And why would that be? That's a good question. I think. Does anybody maybe know why this is happening? I hopefully do. So when we are doing this capture, we are not actually capturing this recompute. While we might think so, we are capturing self here. Yeah, tricky thing. But if we capture recompute here, then we will capture this reference, and this reference will be the same each time. And if we run this again, and I hopefully don't. If we run this again, we should see this changing once, or 0 time. This should be get called once, but I didn't put the breakpoint here, so we'll have to do this. Okay, and if you can see this context now is actually the zoom talks recompute. So this is on zoom. This is actually this. It doesn't always match one-to-one. You cannot always see what's in this. Capture list this way, but in this time we can. And we can see this reference doesn't. This reference doesn't change. This doesn't change. So this body will not get recomputed. And that's basically like the gist of it. But the problem is now why did this get recomputed if we put self here? So like it doesn't make much sense. I mean it's pretty much the same. So this we are capturing self, but self just captures this. Well, it's a bit different because self doesn't capture recompute, it captures state object of recompute. And if we run this again, we will see the same behavior. We will not. Now we will see the same behavior. Oh, go. Okay. Same, okay. Go away. Same behavior. And now, there has to be something with this state object, and why is that? And we can put a breakpoint here and use this, not here, because here we just see the closure. Let's put it here and actually see what's going on. And if we see self, recompute, and storage, object, seed. And these are all structs, by the way. This is not structs. These are value types. So when SwiftUI is diffing this, it will reflect on this, on this, on this, and it will come to this seed. And if we run this enough times, we see that this seed actually changes. So this seed changes each time when object will change is called on this state object, not this state, on the object inside the observable object, the publisher. Wait. This. Every time you send an event to this, the seed changes. And that is necessary for, if we have the time, I'll talk about it, but for now, no, this seed changes, and that's why this we're causing this body to recompute. Cool. Questions, maybe? No? Then let's carry on. Hand switch. Now, let's check example 3. Now, what else is there actually to... Actually, I'll have to take a sip. What is there else to recompute? Else to diff against? Well, there are actually the very own data structure that SwiftUI uses itself. So, of course, they are special in a way. And is related to what Anteo was talking about with dynamic properties. And let's take a look at the one we are using most often, and that would be the binding. And of course, we are taught by Apple that if we have this binding here, if nothing itself here binds to it, then we don't need to worry about unnecessary body recomputations. And that's true, mostly. So let's start this. We have this count, which is like int. It goes here, and we have this same setup as before. And we are expecting this to not then compute a billion times. But I'll have to switch to another example. Oop. Example 3. So yes, we can see that this only got computed once. Well, I clear this now, but example 3, it's yes, self and identity changed. And that is expected. But this is, of course, not the only way we can use the binding. Let's imagine this is a string. This is a horrible example, but I was not able to think of anything else. Let's think that this is a string, and now for some reason you need to do this. I think this is this. Okay, cool. Now, there were cases where I had to do this. This is not the greatest example, but I think if you use SwiftUI, you did this once before. And if we now use this binding instead of this, then of course things are not going to be working the way we expected. And whenever this content changes, this changes as well. And now I know what you're thinking. This is a trap. Martin must think we are fools because again we are capturing self here, and that. No, I do not think you're fools. There is something else going on here. Even if we capture this count here directly without capturing self, this will get called again. I will, because of the time, I'll let you trust me, but you can check it out yourself. Instead, what is going on that if we put a reference here, and now we can see this binding, we can see how this binding is implemented. Inside of it, it has this location thing. And this is the important thing to do with bindings. Basically, this location is an abstract thing, and states bindings created in different ways have this different location. And when we created it as a function, it always changes. So, as we said, as we understand now how diffing works, this will have to always recompute the body. If you actually use this and store this binding somewhere here, that would actually work, and this wouldn't get called. But because of how this particular location of the binding is implemented, your binding wouldn't work as well. So I do not recommend this. In case you actually do need to do this, I wouldn't say better, but a different way you could do this is just like this, because bindings have dynamic member lookup. You can actually do count dot number replace, and this will now hopefully only get called once. Yes, and whenever we change this, it works fine. So yeah, let me check the time. Okay, so that's I have another example, but it's not really that relevant. I think we can cut it here and go to questions. No, I need to go. Oh, okay. So whoops. Keynote. Run. Go. Questions, if there are some. The last example is not really that related to this. It's a bit related. It's like the origin. Like it's a question. It's an answer to a question. Like it's why I started to take a look at this in the first place, and why it took me 3 weeks to send a button. Because I was trying to figure this out. Okay, cool. Then sure. The stand, please. Okay. So the example, it's not really that interesting in its own right. It's what we have. It's what we have here. So it's a bit different, as you can see, and we are actually presenting a sheet. And in a project of ours, at one point, we had to do a custom sheet presentation, which if you hadn't done this, it can be quite tricky. But the problem is because this sheet has this dismiss in the environment. This is actually where we had an issue. We were doing this incorrectly. So we were using observed object here. And when we had this body called twice, and since we were using observed object, we had double the initialization. Of course, that's an issue on our side, and we later fixed it by doing this, by doing the state object thing. But originally, I was wondering why is SwiftUI not doing this? We're doing the same thing. We are like, wow, what are they doing differently? And I'm just going to run this to show example 4. And yes, you can see this. Okay, this has things for before, but this does get called once only. I'm just going to do this. Again, goodbye, hello, hello, yes, and it's going to get initialized at once. Yeah, cool. And the first approach we did, which makes a lot of sense, we actually stored this as an environment, no capture, I think it's this. We store this entry as, entries didn't exist at the time, but this was basically the logic. We stored a closure in the environment called myDismiss, and we had this sheet logic, and we were using myDismiss here. And I'm going to just, I don't know what's a good way to do this. So I don't think this might work correct, but let's try. myDismiss, and we had this like pitfall. Is presented equals true, yes, or false. I don't know. Doesn't matter. But you can see what we did wrong here. Basically, we captured self the same way we did previously, and then this recompute got captured, and that's why what was causing our body to reload a lot of the time. But that's not really that relevant. But then I'll just show that this is what is happening. Potentially, yes, it's changing all the time. But if you put this, let's go back to dismiss here from SwiftUI. And take a look at what SwiftUI does inside. It handles things a bit differently. And let's put a breakpoint back. Come on. Am I what? Because it doesn't get called. Okay, so I have to rerun this. Sorry. Oh, actually, I could. Never mind. Okay. Sorry. And now we can take a look at to see what dismiss. Dismiss isn't a closure, by the way. I mean, I'm assuming maybe you know that, but it's a dismiss action that has this call as function thing that then calls it regularly. And then if we look inside this dismiss content, you can see this dismiss action is actually a binding, which I found surprising. It's not even storing a closure; it's storing a binding, meaning that SwiftUI does something like this. Sorry. Underscore and dismiss action. It's something like this, and then it actually this call as function triggers this binding, which then triggers somewhere else. And you can also get an example of this because if you take a look at how this binding is implemented, it's all related to this location. This location is actually this box which inside contains should contain. Okay, this doesn't load, but this location inside of it contains. Okay, sorry. Let's do this. Let's do just this now, and then you'll see this binding here is actually a location, in this case, to the entire navigation controller, and SwiftUI actually has the access to the entire navigation controller inside of that. It's pretty changes location. So you can see any location base. You can see here. Not this. Is this host? I see this UI hosting view, and inside has actually a reference to the entire navigation stack. And with that, it knows how to push, pop, do the things you need. And that's the similar thing for how we could have done it as well. In the end, there was no need for this because the app was running fine. We just changed the observed object to state object. It was okay. So yeah, as I said, not much necessarily production value, but it's cool to think about. That's then my last example. I'm done. Cool. Any questions for this or previous parts? I don't know. Cool. Okay, cool, nice. Then thanks.